Hello, today we will do 11.4 review day 1. Go ahead and pause the video to start your do now. All right, to do these half-life problems, the most difficult part is to determine the T. The T is the number of half-lives in a given time period. So the half-life of cobalt-60 is approximately 5.25 days. Find the amount of cobalt-60 left from a 30-gram sample after 42 days. To find the T that we need for this, we need to divide the 42 by 5.25. So you would get your graphing calculator out. 42 divided by 5.25 gives you a T value of 8. The original amount of the substance is 30 grams. So you would do 30 times 0.5 to the 8th power. Go ahead and type that into your calculator. You should get approximately, I'm going to round here, but the calculator says 1.1171875. We could just round that to 0.117 grams. And the tester quizzes will tell you what to round to. All right, we're going to go through this packet today just by reviewing a few problems from 11.1 through 11.4. If you remember, the first lesson was all about geometric sequences. For number 1, we need to determine the R, the common ratio, what we're multiplying by each time. In this case, we're clearly multiplying by a -4. So we can just continue multiplying by -4 on our calculator. -384 times -4 would get me 1,536. Multiply that value times -4 would be -6,144. And multiply that value by -4, you get 24,576. The next type of problem with geometric sequence is using the formula. We have to find the first term, the common ratio, and don't forget to raise that to the n-1. The only time we use this formula is when it says geometric sequence. So the first term is -10, the common ratio is 0.5, and we're looking for the 5th term. Remember, if you're going to type that in on your calculator, make sure you put the 5 minus 1 in parentheses. Or if you're like me, you would just type in -10 times 0.5 raised to the 4th power, which is -0.625. All right, to graph this is a very complicated looking graph. I'm going to show you how to type this into your calculators. So let's go to the y equals setting on the calculator in the top left corner, and we're going to input this equation. I'm going to put left parenthesis, -1 divided by 2, right parenthesis. That encloses the -1/2. And then I'm going to start a new parenthesis, 1 divided by 5. I'm going to close the parenthesis and then raise it to the x power. Now you can look at a picture by pressing graph, or what's more important and more helpful here is pressing second graph to find the table of values. You can go up to find some negative numbers and some positive numbers, and I'm just going to take those values and put them into the table. Let's go with -3, -62.5, that won't fit on my graph, -2, -12.5, -1, -2.5. There's usually only a few points that will fit on your graph, so don't worry if your graph is not quite the way you want it to look. That's how exponential graphs are. All right, so -3, -62.5, that's off my graph. -2, -12.5, -1, -2.5, 0.5, and it just keeps getting closer to the x-axis, but it will never touch the x-axis and it will never cross. So be careful with your arrow right there. All right, now we're into exponential functions where they give me the whole equation and I just have to plug in 5 for the x on my calculator. Don't overthink it. Don't change the formula. This is really just calculator work and you should get 1.11 feet. For 5, is this exponential? So for exponential, we're looking that we're multiplying the y values by the same amount each time. And in this case, from 160 to 140, I'm multiplying by 0.25 or 1/4. Let's see if that continues to work. From 40 to 10, sure enough, I'm multiplying by 1/4. Some of you think of that as dividing by 4. It's the same thing. So yes, this is exponential. The y values are being multiplied by 1/4. Or 0.25. All right, number 6, we're investing money. Compounded monthly. As soon as you see compounded, we're going to use that compound interest formula. All right, so monthly means my n value would be 12. I need my rate to be as a decimal 0.03. My time in this case is 5, and my initial amount is 1,500. So 1,500 times 1 plus 0.03 divided by 12 raised to the 5 times 12. Oh my goodness. Now this might take a few tries on your calculator to type it in correctly, but once you do, you're going to get $1,742.43. I would type it in piece by piece. In fact, let's take a look at this. Let's go to our calculator and let's start with the 0.03 divided by 12. So I'm starting inside the innermost parenthesis, plus 1. So now we've simplified our equation, and we can write this as 1,500 times 1.0025 raised to the, and if you need to, you can even do that part. You can do 5 times 12. Just to check, okay, it's 60. Now this should be easier to type in, and hopefully that helped you find the correct money amount. I round to hundredths because this is money. Oops, I'm sorry, too much erasing. All right. A pond of fish has 150 fish. The population decreases, so I right away know I'm using my exponential decay formula. Use your context clues. My rate would be 0.08, not 8. So let's type this in here. We've got 150 times 1 minus 0.08. They're trying to trick you here. 3 weeks. We're not typing in 3, everybody. We're going to type in 21. 7 times 3, 21. And we're going to round to a whole number because we do not want to chop these fish up. So we get 26 fish. All right. 26 fish, sorry. Okay. Number 8. Is this linear, exponential, quadratic, square root? We have not studied square root functions yet, so I would not choose that option. You have a few choices. You could graph it, but the graph's going to be misleading. So I'm going to look at the y values. I'm not adding or subtracting the same number each time. Let's double check if I'm multiplying. So on my calculator, I'm going to do 12 divided by 15. I did the second y value divided by the first y value. Now let's try the next one, 9.6 divided by 12. Sure enough, I am multiplying by 0.8 each time. And when I know I'm multiplying by 0.8, that would represent an exponential function. The graph is misleading. If you plot these points, it kind of looks like a line, but it's not. So beware. If you see a problem like this on your quiz or test, even though it looks like a line, it's just because you don't have the zoomed out version of this. The zoomed out version will eventually look like a decreasing curve. Okay, and that's it for today. Thank you very much. Have a great day.